You have decided to change something about yourself. Maybe more than once. Maybe many times. You decided to exercise, to eat differently, to stop checking your phone every 5 minutes, to go to sleep earlier, to finally learn the language, finish the course, build the habit, start the project. And you did change, for a week, maybe 2. You felt different. You felt proud of yourself in a way that felt new and possible and real. And then, quietly, without drama, without a conscious decision, you went back. Not all at once. Gradually. The old patterns reasserted themselves as if they had simply been waiting. As if the new version of you had been a temporary visitor in a life that belonged to someone else. And you asked yourself the question that lonely people ask about loneliness, and procrastinators ask about procrastination, and almost everyone asks about every failed attempt at change. What is wrong with me? The answer, according to neuroscience, is nothing. This is not weakness. This is biology. And understanding it, truly understanding why the brain resists change at the level of structure and chemistry, is the first step toward doing something about it. Welcome to Lumina Slow English. I am speaking slowly and clearly so you can follow every word. This is real neuroscience. This is real English. Let's begin. Let's start with the most important thing the brain does. The thing it is most fundamentally optimized for. Efficiency. The brain is, above everything else, an energy conservation machine. It accounts for roughly 2% of your body's weight, but consumes approximately 20% of its energy. This is expensive. Metabolically speaking, thinking is one of the most costly things a human body does. And so the brain, over millions of years of evolution, has developed an extraordinarily sophisticated system for reducing that cost wherever possible. That system is called habit. When you repeat a behavior often enough, under consistent enough conditions, the brain takes it out of the hands of the slow, energy-intensive, deliberate thinking system, the part of your brain that weighs options, considers consequences, and makes conscious choices, and hands it to a faster, cheaper, automatic system that can execute the behavior with almost no conscious input at all. This is not a flaw. It is one of the brain's greatest achievements. Without it, you would have to consciously decide, every single morning, how to brush your teeth, how to tie your shoes, which route to take to work, how to navigate the social dynamics of every routine conversation. The automaticity of habit frees your conscious attention for genuinely new problems. It is the brain running old software in the background, so the processor can focus on what is actually novel. But here is the problem with this extraordinary efficiency. When you decide you want to change, when you decide the old software is not working and you want to install something new, the brain does not immediately cooperate. The old patterns are deeply encoded. They are fast. They are cheap. They are associated with known rewards. And the new behavior is slow, expensive, effortful, and uncertain. From the brain's perspective, change is not an upgrade. It is a disruption. In 2006, Charles Duhigg, a journalist and author, began investigating the science of habit formation. His research led to a book called The Power of Habit, which became one of the most widely read accounts of how automatic behavior works. At the center of his framework was a structure he called the habit loop. The habit loop has 3 parts. The first part is the cue. The cue is a trigger, a signal from the environment that activates the automatic behavior. It might be a time of day, an emotional state, a physical location, a specific person, or a sensory experience. The cue tells the brain, this particular routine is about to begin. The second part is the routine. The routine is the behavior itself, the automatic sequence of actions that the cue initiates. It can be physical, like reaching for your phone when you sit down. It can be mental, like the cascade of worried thoughts that begins when you encounter a stressful email. It can be emotional, like the familiar sinking feeling that follows a specific social interaction. The third part is the reward. The reward is what the brain receives at the end of the routine, the signal that this loop was worth running. The reward might be pleasure, relief, stimulation, comfort, social approval, or simply the reduction of discomfort. It does not need to be large. It just needs to be reliable. Cue, routine, reward. When this loop repeats consistently enough, it becomes encoded not in the deliberate thinking parts of the brain, but in a deeper structure called the basal ganglia, a region at the base of the brain that manages automatic, learned behaviors. Once a behavior reaches the basal ganglia, the prefrontal cortex, the part of the brain responsible for conscious decision-making, essentially goes quiet during its execution. You are no longer choosing the behavior, you are performing it. This is why habits feel automatic, because neurologically they are. Vocabulary pause. Let's stop and name 3 words you have been absorbing in context. The first, neuroscience. Neuroscience is the scientific study of the nervous system, including the brain, the spinal cord, and the networks of neurons throughout the body. When we use the word neuroscience in this video, we are referring specifically to brain science, how the brain is structured, how it learns, how it changes, and why it sometimes resists changing. Neuroscience is not philosophy or opinion. It is the study of what is physically happening inside the organ that produces all of your thoughts, feelings, habits, and decisions. The second, automatic. Automatic means happening without conscious intention or deliberate effort. An automatic behavior is one you perform without deciding to perform it, without thinking about it, without choosing it in the moment. Most of what we do each day is automatic in this sense. We do not decide to blink. We do not decide to understand the words on this page. And after enough repetition, we do not decide to reach for our phone or make coffee or follow the same familiar emotional patterns. They happen. That is what automatic means. The third, circuit. In neuroscience, a circuit is a network of connected neurons that fire together in a coordinated pattern. When you learn a skill or form a habit, you are building a circuit, a physical pathway in the brain that, once established, can be activated quickly and with little energy. The word is borrowed from electronics deliberately. Just as an electrical circuit lets current flow along a defined path, a neural circuit lets information flow along a defined route. The older and more used the circuit, the faster and easier it runs. Neuroscience, automatic, circuit. Now let's go inside the brain. Because understanding the physical architecture of habit and resistance to change requires knowing 2 specific structures and what happens between them. The first structure is the prefrontal cortex. Located at the front of the brain, directly behind your forehead, it is the most evolutionarily recent part of the human brain. It is responsible for deliberate thinking, planning, reasoning, weighing consequences, making decisions that require considering the future rather than just responding to the present. When you think carefully about whether to eat the second piece of cake, when you pause and reason through it, that is your prefrontal cortex working. The prefrontal cortex is powerful and precise. It is also slow and expensive. It requires significant mental energy to engage. It fatigues over the course of a day, and it is easily overridden by faster, more emotionally urgent signals from deeper brain structures. The second structure is the limbic system, a collection of older brain regions that manage emotion, motivation, memory, and survival instincts. The limbic system includes structures like the amygdala, which processes threat and fear, and the nucleus accumbens, which processes reward and craving. The limbic system is fast. It operates below conscious awareness, and it has a direct line to behavior that bypasses deliberate thought entirely. When you decide on a Monday morning that you are going to exercise every day this week, that decision is made by your prefrontal cortex. It is rational, forward-looking, fully intentional. You mean it completely. When Wednesday evening arrives, and you are tired from work and the couch is right there, and exercise suddenly seems much less necessary, that experience is your limbic system doing what it was built to do, responding to the immediate present, favoring the certain comfort of now over the uncertain benefit of later, and running the habit loop that has been reliably rewarded in the past. This is not a failure of character. It is a structural competition between two brain systems, one newer and more rational, one older and more powerful. And in conditions of fatigue, stress, or low blood sugar, the older system wins more often than the newer one. Wendy Wood, a psychologist at the University of Southern California who has spent decades studying habit formation, found that approximately 43% of our daily behaviors are habits, actions performed in the same context, in the same way, with little or no deliberate intention. Nearly half of what we do each day is automatic. The prefrontal cortex is not in charge of most of our lives. The basal ganglia is. Vocabulary pause. 3 more words. The first, basal ganglia. The basal ganglia are a group of structures deep inside the brain, below the cortex, that play a central role in learning and executing automatic behaviors. When a behavior becomes a habit, when it has been repeated often enough in a consistent context with a reliable reward, control over that behavior shifts from the prefrontal cortex to the basal ganglia. The basal ganglia then execute the behavior efficiently, quickly, and without conscious input. This is why habits feel effortless once they are established. The brain has literally moved the behavior to a cheaper, faster system. Second, prefrontal cortex. The prefrontal cortex is the brain region behind your forehead responsible for deliberate, rational, future-oriented thinking. It is the seat of willpower, planning, and self-regulation. It is also the region most vulnerable to fatigue and stress, which is why difficult decisions made late in the day, or when you are emotionally depleted, are more likely to default to habit and impulse rather than intentional choice. The prefrontal cortex is the newest part of the brain. It is also the first part to go offline under pressure. The third, reward. In neuroscience, a reward is any outcome that reinforces a behavior, that makes the brain more likely to repeat it in the future. Rewards activate the nucleus accumbens and trigger the release of dopamine, the brain's primary learning signal. Importantly, rewards do not need to be pleasurable in an obvious way. Relief from discomfort is a reward. Reduction of anxiety is a reward. The brief distraction of checking a notification is a reward. Anything the brain registers as a positive consequence of a behavior will strengthen the habit loop accordingly. Basal ganglia. Prefrontal cortex. Reward. Now I want to tell you about Jeffrey Schwartz. In the 1990s, Schwartz was a psychiatrist at UCLA studying obsessive-compulsive disorder, OCD. OCD is a condition characterized by intrusive, repetitive thoughts and compulsive behaviors that the person performs in response to those thoughts, even though they know intellectually that the thoughts are irrational. People with OCD are not confused about reality. They know the thought is not logical. They perform the compulsion anyway. Their prefrontal cortex can see the problem clearly. Their deeper brain circuits override it. Schwartz developed a treatment approach based on a radical idea that patients could use their own conscious attention to physically change their brain circuits, not through medication alone, not through talking about the problem, through a specific, deliberate practice of directing attention differently and doing so consistently enough that new neural pathways were built to compete with the old ones. He called his method self-directed neuroplasticity, and it was built on a concept that was, at the time, deeply controversial: neuroplasticity. Neuroplasticity is the brain's capacity to change its own physical structure in response to experience. For most of the 20th century, scientists believed that the adult brain was essentially fixed, that the neural architecture you had as a young adult was the architecture you had as a young adult was the architecture. Neurons could die, connections could weaken, but new growth and fundamental restructuring were thought to be impossible after a certain age. This turned out to be wrong, completely wrong. We now know that the brain retains the capacity to form new neural connections, strengthen existing pathways, prune unused circuits, and reorganize itself in response to experience throughout the entire human lifespan. It does this more easily in youth, but it never stops. An 80-year-old brain can build new circuits. A deeply encoded habit can be replaced by a different deeply encoded habit. The brain that resists change is not a brain that cannot change. It is a brain that has not yet been given sufficient, consistent, correctly structured experience to change. Schwartz's four-step method, developed for OCD but applicable to almost any deeply ingrained behavior, offers a precise framework for how deliberate change actually works in the brain. The first step is relabel. When you feel the pull of an old habit, the urge, the craving, the automatic impulse, you name it explicitly. Not "I want to check my phone," but "my brain is sending a craving signal." Not "I can't do this," but "my brain is generating a fear response." You separate the signal from who you are. The thought is not you. It is a circuit firing, and circuits can be changed. The second step is reattribute. You identify the source of the signal, not character, not weakness, but neurology. This is my basal ganglia running a familiar loop. This is a brain event. Reattribution does not eliminate the discomfort of the urge, but it strips it of its authority. An urge that feels like a truth about who you are has enormous power. An urge understood to be a predictable electrical pattern in an old circuit has considerably less. The third step is refocus. Instead of acting on the old circuit, you deliberately direct your attention to a different behavior, one that begins building the new circuit you want. You do not suppress the urge. You redirect attention. The neurological principle here is crucial. Where attention goes, neural firing follows. By consistently redirecting attention to the new behavior, you are literally feeding the new circuit and starving the old one. The fourth step is revalue. Over time, with consistent practice of the first three steps, the old urge loses its intensity. Not immediately, not without effort, but gradually the automatic pull of the old circuit diminishes as the new circuit grows stronger. What was urgent becomes less urgent. What was automatic becomes a choice again. Relabel, reattribute, refocus, revalue. This is not a metaphor. Schwartz documented the neurological changes in his patients' brains using imaging technology. The circuits visibly changed. The brain physically restructured in response to consistent, deliberate attention. Self-directed neuroplasticity was not a theory. It was a measurable, observable biological event. Vocabulary pause. 3 final words. The first, neuroplasticity. Neuroplasticity is the brain's capacity to change its own physical structure, to form new connections, strengthen existing pathways, and weaken unused ones in response to experience, learning, and directed attention. The brain is not fixed. It is plastic, permanently capable of being reshaped by what you repeatedly think, feel, and do. The word combines neuro with plasticity, the quality of being moldable. Your brain is, in the most literal sense, what you repeatedly practice. The second, deliberate. Deliberate means intentional, conscious, and purposeful, done with full awareness rather than automatically or by default. In the context of neuroplasticity, deliberate attention is not just psychologically important. It is neurologically necessary. The brain changes in the direction of sustained, focused attention. Scattered, passive experience produces far weaker neural changes than deliberate, purposeful engagement. Every moment of deliberate practice is a real event in the physical brain. The third, intentionality. Intentionality is the quality of acting from conscious purpose, of directing attention and behavior from intention rather than from habit, impulse, or default. In the language of this video, intentionality is what the prefrontal cortex brings to behavior that the basal ganglia cannot. The capacity to choose differently from what is automatic, to build the future rather than simply repeat the past. Intentionality is not about forcing yourself through willpower. It is about consistently directing attention toward what you actually want to become. Neuroplasticity, deliberate, intentionality. So here is what all of this means for you. The next time you try to change something, a habit, a pattern, a default response, a way of moving through your days, and you feel the pull of the old behavior asserting itself with surprising force, here is what is actually happening inside your brain. Your basal ganglia is running a well-worn circuit. Your limbic system is presenting the familiar reward as the path of least resistance. Your prefrontal cortex, depending on how tired or stressed or depleted you are at that particular moment, may or may not have the resources to override it. This is not a moral failure. It is not evidence of weakness or inconsistency or lack of commitment. It is a competition between two neurological systems with different speeds, different costs, and different evolutionary histories. The old system is not trying to sabotage you. It is doing exactly what it was built to do, running the known, the proven, the reliable. The behavior that has been rewarded before, rewarded in the sense of producing a familiar outcome, not necessarily in the sense of serving your long-term interests. And here is what the science of neuroplasticity says about that competition. The newer system can win, not immediately, not without repetition, but it can win because the brain does not care which circuit runs. It is not loyal to your past self. It is loyal to whatever is used most frequently, most reliably, most consistently. Feed the new circuit enough and the brain will eventually run it with the same automaticity, the same cheapness, the same effortlessness it currently brings to every habit that feels impossible to break. Every time you notice the automatic impulse and choose something different, every time you relabel the urge, redirect your attention, and take even one small action in the direction of who you want to become, you are doing something neurologically real. You are not just performing willpower in a vacuum. You are physically remodeling the most complex organ in the known universe. You are adding one thin layer of myelin to a new pathway, making the next version of this choice measurably easier than it was today. Myelin is worth understanding clearly. It is the fatty substance that wraps around neural pathways, insulating them the way rubber insulates a wire. When a pathway is well myelinated, signals travel along it up to 100 times faster than along new, unmyelinated pathways. This is what consistent practice actually builds, not just familiarity, not just confidence, but physical speed encoded permanently in the structure of the brain itself. You cannot feel this happening. but it is happening every single time you practice the behavior deliberately. This takes longer than a week. It takes longer than the commonly repeated 21 days that appears in popular culture without scientific support. Research by Wendy Wood and others suggests that simple behavioral habits take between 2 and 8 months of consistent repetition before they begin to feel genuinely automatic. Complex changes in emotional response, in communication patterns, in how you approach creative or intellectual challenges take longer still. But here is what matters more than the timeline. Every repetition counts. Every deliberate choice is a real biological event. Every moment of intentional attention is a measurable change in the brain that runs your life. There is a specific kind of patience that this requires, not the passive patience of waiting for something to arrive, but the active patience of continuing to practice when the results are not yet visible, of relabeling the urge on the days when relabeling feels pointless, of taking the small action when the small action feels inadequate, of trusting the mechanism even when the mechanism produces no immediate reward you can feel. Because the brain is not keeping score in a way you can see. It is keeping score in the language of myelin, in a way that will only become visible after enough repetitions have accumulated to cross the threshold from conscious effort into something that simply feels like who you are. The brain that has resisted you is the same brain that will ultimately cooperate with you, not despite its efficiency, but because of it. Once you give it a new pattern that is consistent, reliably rewarded, and sufficiently practiced, it will run that pattern with the same effortlessness it currently brings to every behavior you have been trying to change. The question has never been whether your brain can change. It can. The question is whether you will give it what it needs to change. Time, repetition, and the right kind of deliberately directed attention. Not a single heroic effort. Not a perfect streak. Just consistent practice, repeated patiently, until the new circuit becomes faster than the old one. That is the actual mechanism of change, not motivation, not discipline, not a better morning routine or a more powerful habit tracker. A well-fed circuit, built one repetition at a time, until it runs itself. Before you go, I have one question for you, and I want you to answer it in English, in the comments below. Think of one change you have tried and failed to make, something that kept reverting to its old shape no matter how many times you tried. And tell me, what is one small, concrete action you could take in the next 24 hours, small enough that your brain cannot argue against it? Not a transformation, not a new identity, just one action, one repetition, one thin layer of myelin on a pathway that could, with enough patience, become the most natural thing you do. One sentence. In English. That is all. I will read them. This was Lumina Slow English. I am glad you stayed until the end. And I will see you in the next one.